There are several things that happen to you as you get older. One thing is that you get better and better at pattern recognition. All that life experience allows you to take mental shortcuts and make quicker decisions. But the truth is, you're just not as likely to run to catch the bus like you once did. And the name of that movie you saw a few weeks ago, what was it again? And bending down to pick something up is something you have to think about and do carefully. But this is all part of nature's plan, right? People get old, then they die, so new generations can come forward. But what if you could change nature's plan? What if you could radically slow down or even suspend the ageing process and live for much longer, even much, much longer, and hold off all that creeping decrepitude that seems to be built into us? If that technology was available to you, would you use it? David Sinclair is here to tell you that science is making serious inroads into stalling the ageing process. David Sinclair is an Australian-born biologist who is a professor of genetics at Harvard Medical School in the United States, and he's written a book called Lifespan. And David will be appearing on a panel discussing longevity at the World Science Festival in Brisbane this year. Hello, David. Welcome.
Hey, Richard. Thanks for having me on.
In the dedication of your book, you've written, "To my great-great-grandchildren, I am looking forward to meeting you." Is that just a bit of fun, or do you really mean that?
Well, I have no idea, but I think the chances of us all living much longer than we think is extremely high. You know, I think that the way things are going, I'm probably going to live a lot longer than I would have otherwise. I'm now 52 and, I'm measuring things. I'm seeing myself, how old I am. I can tell how old I am. We can now measure how old each of us is. And my age is a lot slower than it would have been if I hadn't been doing certain things. So I don't know if I'm going to see my great-great-grandkids, but I do know that I'm using all that science has to live as long as I can just to see if it's possible. What's
a realistic expectation for you at the moment when you want to look at the kind of lifespan you're aiming for, David?
Yeah, so I was born in the 60s, right? And so people like us and those before me are really unlucky enough. Unfortunately, we were born one generation too early. And I'm doing my best to bring technology forward as fast as possible and help us, those of us who have lived through the 20th century. So those of us of my age and a bit older, only a few % of us make it to 100 years of age, centenarians they're called. Those who are born today, even if I'm not successful with my drugs that I'm working on, and others of course, they will, or at least they're predicted to live, many of them, to 100. In fact, 30% of people born today should make it to 100. Now that's a dramatic shift in society and what individuals should regard as their arc of life. But I want to make sure everybody who's listening knows that there is a revolution in the science of aging and understanding what we can do to slow the clock down to give us easily a 15-year extension of healthy lifespan.
You don't see ageing so much as a natural process but as more of a kind of disease. Why is that?
Well, a disease is simply something that happens over time that's bad for you and makes you sick and frail and often kills you. And that's exactly what aging is. The reason that we don't call aging a disease is very simple. The medical dictionary defines a disease as something that happens over time, that hurts you, makes you ill, that happens to less than half of the population. Okay? That's an arbitrary cutoff. And you might say, well, aging's natural. It happens to everybody eventually. Well, so does cancer. Cancer will kill you if you live long enough. You can't avoid it. That's part of the natural course of human existence. And so just saying that it's common isn't sufficient to say that we should accept it. It would be like saying, 100 years ago, we should have accepted that cancer was natural and therefore we shouldn't have even done any medical research. In fact, I would argue that working on aging is more important than working on really any other ailment because it affects so many people and also because when we understand it, and I believe that we do have a good handle on it now, we will be able to slow it down and intervene with medicines effectively. And when we do that, future generations and even our generation will look back at times before it and wonder why we didn't work on it sooner. Because the advantages are that we can stop or at least slow down the progression and formation of these diseases that kill us before we have to start slapping Band-Aids on, which is the current approach to medicine.
So broadly speaking, what's happening to our bodies and to our genes as we age?
There's been a revolution in our understanding starting from about 30 years ago. Actually, if we go back to, give me 80 years ago, humans discovered that if you restrict the calorie intake of animals, they live a lot longer. And so putting the body in a state of want turns out to be very good for you, just not that pleasant. A lot of people are doing that today, and often I joke that you may not live longer, but it'll certainly feel that way. And what we've been working on, my colleagues and I, for the last 25 years over here in the US, is to understand how is that diet, calorie restriction, we now call it often intermittent fasting or time-restricted feeding, how does that work? Because if you can understand how it works, you can bottle it, you can put it in a pill, put it in an injection, an IV, and turn on what we now know are the body's defenses against aging that until recently could only be turned on by changing how much you eat.
How would you describe what's happening at a cellular level, though?
Well, so if we go back to high school biology, the cell has two types of information in the body. There is the DNA, which is the digital information that we get from our parents. It's digital because it's just 4 chemicals, A, C, T, G for short. And it gets copied, and over time it degrades, and we lose some of that information. And that was the leading theory for the last 30, 40 years.
So when cells replicate, it's like taking a photocopy of a photocopy of a photocopy, in other words.
Well, it is, but that's an old theory. That one's not turning out to be the main cause of aging, though it plays a small role. And the loss of the chromosome ends, called telomeres, that was a leading theory. But it just turns out that that's not a major cause of aging. It's part of it, and there's lots of things that go wrong during aging. And I could list 8 hallmarks of aging, one of which is the loss of genetic information, of which telomeres are part of. But there's a new revolution in our understanding of really what's going on in aging. And that's not the genetic information, it's the other major type of information in the cell that we often forget about. And that's called Epi Genetic Information. And if you've never heard of epigenetic information, it's analogous to the reader of the genes, the reader of the DNA. And if you're old enough, you've actually played a compact disc. And it's similar to that in that the digital information, which is the music encoded in the little silver holes in the disc, I represent that as the DNA of the cell. The reader, remember the laser that would scoot around and read the music, that is analogous to the epigenome. Okay, and that information is the part that is lost over time that I believe causes aging. And that's good news, because what aging really represents is scratches on a CD. And anyone who's had a CD knows you can polish those scratches off and get back the ability to read the music again. And the analogy of the cell works here because we believe we've figured out what causes those scratches so that the cell doesn't read the genes correctly. But more importantly, last year we published a safe way to polish those scratches and get the cell to read the genes correctly again so that it could not just act young, but literally be young again.
There's there's the selfish gene theory, which says that one of the reasons why humans get old, if you can say it's a reason, is that the human body, after they've passed the age of procreation, you sort of surplus to requirements then as far as your genes are concerned. Once you can't procreate and pass the genes on, well then there's not as much point, if you like, for humans at a genetic level. What do you think of that theory, David?
Well, that's true. That doesn't mean we can't change it. I mean, there's a reason we get We get blind as we get older. We can't read. We're not as strong. It's all those. It's a lack of forces of natural selection at old age. But we still fix eyes. We treat cancer. We fix bones, and we can fix aging. In fact, treating aging is going to be much simpler than curing cancer. Much simpler. We now understand that there are genes that control how fast we age and prevent those scratches from happening. And we've even found genes that can reset the system.
You say in your book that your grandmother was a big influence on your thinking when it comes to aging. Tell me a bit about her and her background.
Well, she's got what I am referring to in my next book as the FU gene. She was a rebel. She grew up in really the early parts of World War II and had one son, my father, and they survived World War II and helped a lot of other people survive. But also in Hungary, in Budapest, there was a revolution to fight against the Russian occupying forces, which didn't last long, and then the Russians cracked down on the rebels, and my grandmother was one of them. So she fled for her life with bullets flying over with my father, her son, made it into Austria and then got on a boat to get as far away from Europe as possible. And she made it to Australia and never went back. But got to Australia and just found it to be the best place on earth with freedom and great weather and ended up, because she hadn't raised, a lot of people don't ask this, but I'll tell you, my grandmother became pregnant in high school and at the age of 15. And so her son, my father, was taken away from her. Imagine how that feels. And so she didn't raise my father. So when I came along in 1969, this was her chance to be a mother that she never could be. And I had so much attention smothered on me. But I was fairly spoiled. But what I also got was a wonderful education. She was a philosopher, a historian. And so I was just filled with all of these facts and grew up that way. And what she said to me that really had the biggest impact was a couple of things. One was, David, I asked her, are you always going to be around? And she said, no, I'm going to die, and your parents are going to die, and your cat's going to die, and then you'll die. That's how she spoke, right? She's just no holds barred. And as a 4-year-old, I distinctly remember falling on what was a very prickly 1970s carpet and crying my eyes out. And that trauma still is with me today. And then the second thing that she instilled in me many, many times after that was, David, humans can be evil, but they can also do great good. And your job is to show humanity how great they can be. And so I'm doing my best to live up to her standards and try and bend the needle of human history a little bit towards being better than we actually were in the last century.
You studied biochemistry at the University of New South Wales in Sydney. Tell me how you became aware of the emerging science on longevity in the 1990s.
I was studying yeast cells. These are the same yeast cells you use to make bread and beer. And it was a really useful genetic organism because in those days, different to what we could do now in humans, we could manipulate their genes at will in a couple of days. And we used that organism to understand, for my PhD, a genetic disease that caused people's urine to smell like maple syrup. Which is probably the best disease you can have.
Why yeast, though? Why is yeast the focus of your research?
Well, yeast, it was in the 1990s because you could grow lots of it, and the genes that make up yeast, about 70% are the same as in humans. And I was of the belief, my professor Ian Dawes was of the belief that understanding processes in yeast would tell us very similar things about ourselves, including genetic diseases, but also about aging. And I was always fascinated with aging. I can remember being at a cafe at uni with friends, and they were just talking about stupid stuff, shallow stuff. And I just stopped everybody and I said, do you realize we are probably the last generation to live a normal lifespan? So that was a turning point. I was 18 at the time. And then just fortuitously, or destiny came along, and a professor from MIT called Leonard Guarenti visited Australia to go to a lawn conference, which is in Melbourne, and dropped by Sydney to say hi to my supervisor. Garenti was studying yeast as well. And I went to dinner with him and a few other students. I was a PhD student. And he said that there was a project just getting started in his lab in Boston to understand why yeast get old and are there genes that control that process. And that was the moment that changed my life, because I said to him, I'm coming to work with you, whether you like it or not.
The lab's research was able to identify the role of something called Sirtuins. Can you tell me about them, what they are and what they do?
Yes. So talk about being at the right place in the right time. I got a fellowship to go over to MIT just as they had found some mutants of yeast that lived longer. And when they found which gene was mutated, it was a gene called SIR4, capital SIR4. And it made a protein that was associated with two other proteins called SIR3 and SIR2. And through work that I did and others in the lab did, we discovered the following facts. That are now facts. That the most important gene is SIR2, not SIR4, gives rise to the whole family of genes called Sirtuins, which is now a big field in biology. SIR2, more of it is better, and when you put more SIR2 into yeast cells, they live longer. And we later discovered that SIR2 is what allows hungry yeast to live longer.
How? How does it do that? What does it do?
Yes, so it controls the scratches. It's controlling which genes are switched on and off in a yeast cell. And the SIR, SIR, stands for Silent Information Regulator, number 2. And that silent information is very important. The word information is right there in the name. And that led to this hypothesis, this theory of mine that I described to you earlier, called the information theory of aging, and that the inability to read genes correctly is the cause of aging itself. And that seems to be true now in higher organisms, including ourselves. But in those days, all we knew was that these Sirtuins were important, and that they could, when you got rid of the Sir2 gene, the yeast cells lived shorter and experienced accelerated aging. And then conversely, you make more of them, or you starve the yeast cells, make them hungry, they make more of the Sirtuins naturally, or raise a molecule that turns on this whole process called NAD, which is a chemical that's needed to halt the scratches. And that was sufficient to make the yeast cells live 30% longer. And if you're wondering, how do you know how long a yeast cell lives? You actually have to sit at a microscope for 10 days. You can go home for a few hours while you put them in the fridge, but
you got to look at the microscope all that time? You got to watch them like a babysitter, do you?
You do, and it's worse than that, Richard. You actually have to use a micro dissection needle with a little joystick to move the daughter cells away, because the daughters will have daughters and the daughters will have daughters. So if you don't move them away across the petri dish to the other side, they will just overwhelm the mother. And it's the mothers we wanted to track to see how many daughters they had. And when you had less glucose, made them hungry, or you put in more SIR2 genes, they made more daughters. They had 30% more offspring, and that was what we defined as lifespan extension in yeast cells.
So what are these Sirtuins doing? Are they just really good readers then of that genetic information, or do they actually repair as well?
They do both. So the silent information is really just a way of saying that they shut down genes that shouldn't be on. Now, in the yeast cell, the main genes are the ones that involve fertility or sex. They shut down the male genes when you want to be a female yeast. You probably didn't know yeast have sexes, but they do.
No.
Okay. And then there's a hallmark of yeast aging, which is sterility, because the yeast cells, they lose control over their male-female genes and they don't know what sex they are, and they get confused and they don't mate anymore. And this was known years ago to be a hallmark of yeast aging, and then we figured out that that was the cause. But what's making the Sirtuins malfunction over time, we discovered, is that their other function, as you said, is to repair DNA. They have these two functions. One is to control genes, silence them when they should be off, but they also get distracted by this other process, which is broken DNA, particularly a particular type of DNA damage, which is called a double-stranded DNA break, a broken chromosome, and they fly off the gene where they should be and go and repair the damage. Now, while they're gone, the gene that should be off becomes on, and now the cell has an issue. Why would the cell do that in the first place? It's a strange thing to happen. Well, my theory is that This is a system that stops cells from mating temporarily while they repair their broken chromosome, because you don't want to mate when you're broken. And then the sirtuins come back to where they belong and everything's reset. But during aging, you just get more and more damage and more distraction of the sirtuins. It's like a tennis game. You end up losing balls, and the sirtuins get lost, and they don't know how to get back to where they should be. And this leads to the scratches, the inability to read the beautiful music that's in the genome correctly.
So speaking really simplistically here then, David, this is probably a really dumb question. Why don't we just simply take like a tablespoonful of sirtuins for breakfast every day, and so that there's more sirtuins to come to the rescue to repair the broken genetic damage, and then we just go on for as long as we like?
Well, you can eat protein. It gets digested in the stomach, unfortunately. But there are other ways to turn on sirtuins besides being hungry. And that's been a large part of our work over the last 20 years. There are chemicals that will make the sirtuin enzymes much more active and repair DNA and stop the changes over time. And there are these chemicals we've given to yeast and worms and flies and mice and now humans, and shown the benefits of doing what you just said, but through chemicals.
It sounds not unlike, shoot me down in flames here, it sounds not unlike the immune system insofar as there's this repair system that kicks in when something happens. In order to put these sirtuins to work, do we need to get sick in a way, if you like? Do we need to stress the body in some way to stimulate the production of these sirtuins in humans?
That's what we do. That's the key. What we've learned is that sirtuins get activated when there's something wrong. But you can actually make them think that there's something wrong without actually having anything wrong. We can create what's called an adversity mimetic. Really, we're just telling the cells, either in a yeast or in a mouse, that times are tough, you should work a little harder. And they turn on the sirtuins as a result, even if there's no damage. It's like making a prank call to the military, you know?
I love doing that.
Yeah. Don't do that. I'm not recommending
Don't do that. No. So that's what you do. So you rouse this, then you make the prank call to the military, and the military comes charging in.
Mm-hmm. But here's the amazing thing is that we now know that this is the reason that eating the right foods and not eating so often and exercising is good for you. It turns on these defensive genes because the body thinks that it might not survive, and you get those health benefits.
So it perceives the lack of food when you fast and the tiredness or exhaustion after exercise as a threat, in other words, like a stressor. It's seen as a stressor to the body. Therefore, come on, chaps, off we go, off to the front, in other words.
It is. And the scientific word is hormesis. Another way to put it is what doesn't kill you makes you live longer.
Nonetheless, we don't live those lives like our medieval ancestors did, whereby they worked much harder physically. They would often go hungry. They were often cold in ways that modern people are not as likely to be. Is this your way of saying soft living ages us?
Yes. And so people in history tended not to live a long time because they were deficient in other things. They worked too hard physically, and they didn't maintain their nutrients. But we now know how to science the body. We know how to measure things and tweak things and do things to just the right amount of hormesis, just the right amount of perceived adversity. That's what I've been doing to my body over the last 15, 20 years. We unfortunately have built a world where we like comfort, and we don't like to run. We'd like to sit around. There's lots of food always around for most of us. And that's the worst possible situation. Being overweight and not exercising, we know is not healthy, but it's largely because the sirtuins are not active. And what we found was by activating sirtuins, we could overcome the negative impacts of a high-fat diet in mice. Being obese as a mouse or as a human is not bad for you. It's just that the body doesn't defend itself anymore. So you can actually turn those things on. Now, that's not an excuse to sit around and not exercise and watch movies and eat popcorn, because what we found is that when you turn on these defenses against aging and longevity, and you live a healthy lifestyle, exercise, eat the right foods, don't overeat, you get a massive effect And so if we're going to live really long, you have to do both.
So if I were to have a time machine, and in that time machine I could put a team of doctors with an apothecary full of drugs, send them back to medieval Europe or China or whatever, and if they could get a whole village and inoculate them against every disease and give them antibiotics and tell them how to use them and did nothing else for them, gave them no other benefits of modernity, like wouldn't improve the food supply, wouldn't improve education, wouldn't give them any kind of that kind of technology, just the medical science to protect them against disease, would you suddenly see interesting things with the lifespan of those medieval people who are still being exposed to the stress of hunger and cold and everything else?
Yeah, they'd probably outlive us, as long as they got dental care and other things like that. But yeah, absolutely they would, because their lifestyle, the adversity, was turning on their defenses, but the defenses were not strong enough to combat all of the infections and other things that were around in those days. But yeah, really, we should kind of go a little bit medieval on ourselves once in a while.
This is Conversations with Richard Fidler. To find out more, just head to abc.net.au/conversations.
Tell me about some of the work you're doing with mice at the moment in regards to eyesight, David.
We were working for about 20 years trying to understand what caused aging. And we think we've figured that out, and we can now drive aging forwards. If you came to my lab, Richard, you'd see that we can dial up aging. We can make twin mice. One of them can be 50% older, covered in grey hair, frail, wrinkled skin, osteoporosis, heart disease. We can do that to a mouse now. But what we didn't know until recently was how to slow it down, and even if it was possible to reverse that process. We've been working on slowing it down for a number of years. We've had some success. We use natural and man-made or human-made molecules to turn on these sirtuin defenses in our body. We've been able to mimic the benefits of exercise, make mice run a lot further without having trained. We've made mice resistant to many diseases by giving them molecules. Some of them you'll know. One is resveratrol, comes from red wine. That was a big story, 2003. There's another molecule that is fairly popular right now called NAD. That's also one that boosts the sirtuins. Now that slows down aging in mice, we've shown, and reduces their frailty. Normal mice, not just the ones we accelerate their age. But a real breakthrough happened about 2 years ago, and we published it about a year ago on the cover of Nature magazine, which is a respectable scientific journal. And what we found was a way not just to slow down aging, but to reset the system, to get back the information that we had when we were young, so that cells don't just behave as though they're young, they literally are young. And when we measure them, they're young again.
I don't understand. How can that be done? How do you retrieve lost information like that?
Well, we didn't know if it was possible, but we had a clue from Shinya Yamanaka, who's a Japanese professor who won the Nobel Prize for discovering that 4 genes that are normally only on in embryos can be put into adult cells and make a stem cell again. And a stem cell can then be used to make other tissues, essentially any tissue. I could take your skin cells, Richard, and we do this for other people in my lab, and we grow them into mini little human brains that have electrical activity. They have neurons that look like little brains.
What? What do you mean, mini human brains? That sounds very strange.
It's pretty easy. Pretty much anybody could do it, just need to know how. But we grow these little brains, and we can make them age, we can make them 70 years old, give them Alzheimer's disease. But then the question is, can you reverse that?
Sorry, when you mean, sorry, I'm going to have to ask you this. Mini brains, do you mean like brain tissue or a functioning brain, like a rat brain, or what are we talking about here?
Well, it's mini, but it has the structures, and we can measure its electrical activity, its pulsing, and the nerves fire. We don't know yet if they think or they dream, but they're definitely behaving like a brain. And when we age them, because remember, we understand what causes aging, we can drive them forwards, they lose their electrical activity. They're little pink things about the size of a pea.
If they have consciousness, aren't there huge ethical issues around this?
Yes, I don't know if they're conscious. We treat them very kindly. But yeah, it's interesting that they probably have some kind of thought down there.
When you say small, how small are we talking about?
Just a pea size.
So no bigger than a mouse, in other words, a mouse's brain, in other words.
A little bit smaller than a mouse's brain, yeah.
And what do you do with this manufactured miniature brain?
Well, we study aging, so we can age them. No other lab can do that. We age them, and then we treat them with the discovery, a genetic trick that can reset the age of those brains and get them to be young again. We can turn them back 80, 90% of their age, and they start fresh again.
That sounds vaguely terrifying to me. I don't know. This is like Frankenstein stuff.
Not at all. If you've got dementia, you're going to pray that this works because we are aiming to be able to reverse not just the age of the brain, but to make Alzheimer's disease go away, because there's a reason that young people don't get Alzheimer's. Why does a 12-year-old never, ever get Alzheimer's? It's because a young brain doesn't get it. And we're finding in now mice that when you reverse the age of their brains by 70%, their memory comes back, their ability to learn comes back. And that's the future of medicine, not trying to treat these diseases when they've already happened and aging has taken hold, and we're not doing anything about the age of the brain. That's never going to have a big effect.
And how do you stimulate this process in mice? Do you do it by stimulating the production of sirtuins in these mice?
Well, we drive the aging forward by breaking their chromosomes when they're young, and that distracts the sirtuins, and we get aging, and these are the scratches. But to reverse that is something else. So we remember Shinya Yamanaka has these 4 Yamanaka genes that reset a cell. We found, well, after many trials and a lot of error, that 3 of those genes are safe in cells and that they don't fully reset the cell. They just take it back by 80%, 80, 90% and stop. And that was the breakthrough. We could de-age the cells in the dish, and then they were healthy and they continued. They didn't go to stem cells. They didn't lose their identity. They just went back in age. And so we tried it on a mouse. We put it in the mouse. The mouse was healthy. It didn't get cancer, which was one possibility. And then we decided to do a key experiment. We put those 3 genes using a virus into the eye, gene therapy, and the mice were old and they were blind. And in 3 weeks, we were able to reverse the age of the neurons, the nerve cells at the back of the eye, going to the brain, and the mice regained their youthful ability to see again. And the age of those nerve cells we could measure, and they actually were literally young again. And the pattern of genes that were on and off that was gone in the old cells, the neurons had forgotten what type of cells they are, that were really not functioning in the old mouse, went back to their original state where they were turning the right genes on at the right time, thanks, we think, in part to the sirtuins going back to where they should be.
So the hope here isn't just to find a really good cure for glaucoma. This sounds like the hope is to find treatments that can address cognitive decline, Alzheimer's, dementia, this sort of thing?
Yeah, I think it's early days. It's like the Wright brothers trying to imagine what a Boeing 747 or a Concorde looks like. But the principle is there. And similar to powered flight, we now know that there is a backup copy of a youthful epigenome, the structures of the cell, in all of us. We can turn these 3 genes on that are normally only on in embryos and reset the switch, and cells go back to being young again. And we think we can do this many, many times. There's no reason why we can't do it 50 times. Now, what does this mean? Yes, it means one day someone will be able to reverse the age of the human brain and the eye and the skin and the liver. There is no part of the body yet that we found that does not respond to age reversal. Now, is it perfectly safe? I don't know. The mice are fine. We've been doing this for a few years now. And we have our sights set in about 18 months to do our first blindness study to see if in humans we can restore their vision, if all goes well, and again, if the safety is there.
There's been a lot of dead ends in this field, in the field of longevity research, as you would expect with any science. That's certainly true. I think it was about 20 years ago, I interviewed the Australian scientist Dr. Elizabeth Blackburn, who, with her team of people, won the Nobel Prize for her research into telomeres. And the way she explained it to me was that telomeres are like the shoelace tips at the end, either end of a chromosome. They sort of bind it up and keep all the genetic information in the chromosome intact. And what happens is, as they replicate over time, these shoelace tips wear down and become nubs, and eventually they break open and they're no longer replicating properly. And that team found that the presence of an enzyme called telomerase could repair these telomeres so they could continue and repair themselves properly. But on the other hand, they found that if you start to treat people with telomerase, then the likelihood of cancer goes up. So where is the science on that? And does that figure into your research at all?
It does. And we test every molecule and gene therapy in mice in my lab for their whole lifespan. And then I'm an entrepreneur, so there's companies that are doing this now. And so it's always a risk. We want to know initially if there's any safety issue. But we have treatments now that people have taken for a long time. One of the companies that I spun out of the lab 10 years ago is now showing what we say efficacy. The ability to stimulate the Sirtuins in humans works and actually reverses some aspects of aging. So, yeah, I mean, we always have to be careful, and there are going to be setbacks. I'm not saying that we're there yet. We can't cure aging yet. But I do believe that we've proven without a doubt that there is a backup copy of youth in our cells. And that is a big deal. That means that it will be possible one day. And if you're wondering, well, is this just, some guy spouting off? Then I should tell you this, that since we published our paper in Nature, the amount of investment that's come into this age reset field is over $6 billion of investment. And I know of more coming. So this is more money than's been put into any discovery that I know of. Maybe CRISPR is a more recent one, but I think we're in a world now where I don't need to complete my work for this to happen. Someone's going to do it. And that's good news. I think that train has now left the station.
In the meantime, while we're waiting for this technology that may or may not emerge, but it's looking very interesting, knowing what you know, what are some of the things you're doing in your daily life to slow down the aging process in yourself, David?
Well, there's a lot that I do, but if there's one thing that I would recommend, and if I could recommend, it would be to eat less often. And that's because, unfortunately, nutritionists over the last 30 years have, I think for just reasons that made sense at the time, recommended that we don't feel hungry. And so we also have industries built around that notion. Breakfast is the best, most important meal of the day. Take this snack, eat this bar, don't be hungry. And we've got a world where our bodies, except when we're asleep, don't turn on our natural defenses against disease and aging. So we're aging more rapidly because we've been told you shouldn't feel hungry. Now there's a way around that. You can actually train your body not to be hungry. I don't feel hungry during the day.
How often do you eat during the day?
Well, I have one main meal a day, that's at dinner. And it's a large meal and a very enjoyable one.
And how do you get through the day without food? Honestly, you got a job that requires you to be able to think straight. How do you do that?
Well, it's difficult. So you need to do it in stages. So the first step would be you can either skip dinner or breakfast, but you want to be able to have the sleep cycle go into a period of fasting either in the morning or the night. So I haven't been eating breakfast, not as a rule, but generally I don't eat breakfast, and I haven't done so for the last 30 years. And then more recently, I was eating very small lunches, and then I realized that if I just went for a few weeks without lunch, my body adapted. And I can see this happen. I have little patches that I can put on my skin that measure my blood sugar. And what happened to me when I first stopped eating lunch was that my blood sugar level would decline and I'd get the brain fog and I'd be hungry. This is a hormone called ghrelin that comes out, makes you hungry. But hunger is artificial. There's no such thing as, hunger is just a perceived state. But that low sugar is a problem, right? But what happens over 3 weeks is that your liver wakes up and says, all right, I understand now you don't have food in your village or in your field or in your forest. I'm going to take over. And the liver is really good at making blood sugar by itself. It's called gluconeogenesis. But it takes about 3 weeks for it to do that. It doesn't like to do it generally, but my liver is now trained to start making sugar before I wake up and near perfectly maintain my blood sugar levels at the optimal level throughout the whole day. So I don't feel hungry, and I'm mentally much more capable, and I'm also not distracted by feeling hungry at all. Now, if I want to nibble, and, we're all mammals, we like to put things in our mouths, I'll have some nuts. I had some nuts. I have a little bit of yogurt sometimes. But it's not a meal. I don't feel like eating a big meal until dinner. And then dinner is very pleasurable and big. Now, what I'm doing is keeping those blood sugar levels at a level that's not just perfect for my mental state, and I don't have these brain fogs anymore, and I don't have the highs and lows and crashes and hunger, which is distracting during the day and not good for you. But my longevity genes are on for about 20 hours a day.
Do nutritionists take strong issue with this advice you give?
No, I haven't come up against that yet. So it seems to be becoming more mainstream that a little bit of fasting each day is a healthy thing. And there's actually now a lot of clinical data from humans, studies that show that fasting improves not just your body's biochemical health, which you can measure in a blood test. Inflammation goes down, blood sugar levels, diabetes can go away. But the other thing that happens is there's improved wound healing and there's improved survival of cancer patients when you do this. And so I think that's mainly because it's turning on the body's defenses and putting.
Is there published research on that?
Oh, lots.
Or is this just something that you suspect?
I don't talk about stuff that isn't published. It's this is all very validated in scientific journals.
What about exercise? Increasingly, we're hearing it's better, rather than to just go for a long walk, to actually have a shorter and more intense burst of exercise. Do you have a view on that when it comes to exercising with longevity in mind?
Yeah. Well, I just have a view that's the scientific literature. Again, I'm only science-based. My views don't matter. What the science says is that short bouts of exercise are almost as good as running long distances. And so if I distill the literature down, I would say 3 times a week, 10 minutes, lose your breath. And you're losing your breath when you can't carry out a conversation with somebody. And so that's not very much. If you have a treadmill at home or you like to run, 10 minutes 3 times a week is very doable. And the other thing that's important is to do the other type of exercise. Well, there's 3 types. There's weightlifting, maintaining muscle mass, and then there's stretching and yoga. And that combination of those 3 is amazingly good. So I'm 52, and I'm losing 1% to 2% of my muscle mass every year unless I work out. So I need to do that. And especially for men, you lose testosterone when you don't have big muscles, and that's problematic for a number of reasons. But for women, it's also really important to maintain body tone, body mass, because if you fall over when you're elderly, that's a really short cut to death. Actually, if you break your hip, the chances of survival are about the same as getting a diagnosis of a cancer, a late-stage cancer.
There was a long feature on you and your work in the Boston Globe, and they took an interest in your father. The journalist observed your father and the state of his health, who's been following this regime. Tell me about him and how he's doing at the age of, he's now in his 80s, I believe. How's he doing at the moment?
Yeah, he's 82. So he was trained as a scientist in Sydney. And so some people say I'm experimenting on my dad, which is completely wrong. If anything, I'm saying, Dad, be careful what you're doing. But he can read the science and he believes in me. He's been mimicking my protocols, if you want to call it, for lack of a better term. And so for the last, 15 years, he's been doing what I do. And that includes exercise and eating well. And as I mentioned, skipping breakfast and now lunch. But it also includes some supplements. Now, how's he doing? Well, he's 82. He's got no diseases, no aches or pains. His mental state is as good as it ever was. He's very active socially, physically, walks for miles up and down in his backyard, which is a huge forest, Bobbin Head National Park. So that is my father, and I don't know if it's working, but he's a beacon of hope that you don't have to get frail in your 80s, and he's looking forward to another 20 years of life like this. There's no reason why he thinks that he shouldn't be able to do that.
When I did a story on this 20 years ago, I had to sort of confront a lot of the issues that would follow from people having a radically extended lifespan. One of them is, what are we going to do with all these people who live much longer and stay in good health? Now, I think the point you were making was that this technology won't really be there for Gen Xers like yourself, but there are millennials coming up and about, and they're in rather large numbers. Would this mean you would have older people living well and being kind of unbeatable? Because already older people have the advantage of greater life experience, more money, all those sorts of things. But if they're not suffering the little humiliations of cognitive decline, physical decline, which is gradually going to sideline them, will that stop new generations coming up with fresh ideas, a different take on things, another way of looking at things? Will that lead to a kind of strange stagnation?
The simple answer is no. If you believe that, we should stop all medical research and take away antibiotics and vaccines. So that argument doesn't fly with me and others. We want to give people the longest, healthiest life. And anyone who doesn't believe that, I think, really isn't a good humanitarian. So what we're talking about, though, is things that we can do in our daily lives right now that would give us at least 15 years. If you just do the simple things, eat less often, do some exercise, don't become overweight, don't overdrink alcohol, and have a good social life and have a purpose, get good sleep. Those things are proven to give you, on average, another 14 years of healthy life. And that's not even rocket science. The rocket science that I've been talking about today, I could double or triple that. And that could be in our generation, or it could be for the next generation. But I think it could be here for our generation because, as I mentioned earlier, we've had positive results in human clinical trials that, by the way, interestingly, are sponsored by the US military. We've made mice run twice as far on a treadmill. Now we're doing the same, or working towards doing the same for people. And that's just one advantage of these drugs that we're developing. But what's the problem for society? Well, yeah, you'll have politicians that stick around for longer, and depending on who's in charge, it could be a problem.
We do rely on that a lot, don't we?
Yeah.
for advancing decrepitude, although clearly less and less so, given that the fact that the world seems to be a gerontocracy these days, with people creeping up into their 80s getting into government.
We do, but there's huge advantages to keeping people around for longer in a healthy state. One is the transfer of wisdom and experience. It's a real loss to the world every time somebody dies. There's a huge investment to get somebody to that state. And really, you only get good at your job these days, late in life, and then you get sick shortly thereafter. We need to change that. For women, we can extend their period of fertility so that they don't have to worry about having kids in their 20s and 30s when their careers are taking off. These are the sorts of changes that are coming. And in fact, my lab at UNSW with Lindsay Wu, who runs it, showed that we can reverse female infertility in mice at least. So that's not just speculation that it's possible in mammals. The other reason for doing it is economic. You might think, well, it's going to be expensive to have these older people around. It's actually, we just calculated, and by we I mean a couple of professors in London and myself published, and it's in the journal Nature Aging, that we are looking at a saving of between $86 trillion and $365 trillion over the next few decades, if and when this comes to fruition. That's a lot of money just for the US. And there's no other way to save that much money that we know of.
And yet, when you contemplate changing the nature of society so quickly and so radically, where you're talking about having people with a lifespan of, say, 150, and you are talking about that, aren't you? 150 or thereabouts? That's within reach?
Well, it's within reach for someone who's born today who will have technology of the 22nd century.
So once you look at that, there's going to be this whole cascading series of unintended consequences, changes to human society which have operated in a certain way for a very, very long time. What do you think of that?
Great. Let's change the world. We've seen big changes, and it can be scary, right? Big changes. We managed to fly. We managed to have cars that go super fast. They can be dangerous. But there's always, when these changes happen, there is a fear that something bad is going to go wrong. But when we end up harnessing that discovery, harnessing that power, we don't want to go back. I mean, would anybody really want to go back to the 1900s when you could die from an infected splinter? And, I would wager that most people wouldn't. And if they thought they would, they'd be there for a week and they'd get the heck out of there. It was a dangerous place, and it's going to be the same 50 years from now, where we have biosensors on our skin or under our skin. I already wear biosensors on my body. It's going to be a world where your doctor knows in advance that you're going to get cancer or that you're going to have a heart attack. And the days of going for an annual physical to your doctor will seem medieval. They already do to me. How crazy is that? You go to talk to your doctor and the doctor says, how are you feeling? We have technology now, right here on my shelf here as I talk to you in my bedroom, that I can put on my chest that measures my health 1,000 times a second and will tell my doctor remotely how I'm doing, if I have a cold, and even what kind of antibiotic is needed. That's the world that we're heading into, not in 50 years from now, but in just in a few years.
I interviewed a bunch of people in New York years ago who were transhumanists, and they were part of the Transhumanist Society, which is a kind of a loose collection of scientists and philosophers. And maybe you're a member, I don't know, but this is one of the phrases from their manifesto. I'm quoting here. Intelligence wants to be free, but everywhere is in chains. It is imprisoned by biology and its inevitable scarcity. Biology mandates not only very limited durability and death and poor memory retention, but also limited speed of communication, transportation, learning, interaction and evolution. They say that biological evolution is perpetual but slow and inefficient and blind and dangerous. Technological evolution is fast, efficient, accelerating and better by design. To ensure the best chances of survival, we need to take control of our own destiny and to be free. We must master evolution. Are you on the same page as these guys?
Well, it's a necessity because we continually build a world that's not good for the planet and it's not good for our bodies. And it's technology that's going to get us to survive this treadmill that we've been on ever since we picked up a stick as a tool. And this is what all species that develop technologies are on, this treadmill of fixing the previous generation's problem. And the only way out is more technology to solve the problems. And right now we live in a world that's making us sick, and we need technology to fix that.
Fascinating speaking with you, David, and thank you so much.
Thanks, Richard. It's been great. Thanks for having me on again.
Professor David Sinclair is a biologist and professor of genetics at Harvard, and he'll be appearing on a panel discussing human longevity as part of the World Science Festival in Brisbane. I'm Richard Fidler. Thanks for listening.
Subscribe to listen to more free podcasts or download the ABC Listen app and stream ad-free.